Hello everyone. So let us start with the threading in C++. So in this video, we are going to cover certain topics. Those topics are creation of threads, passing arguments into threads, how can we pass by value, pass by reference, and we will also see what kind of issues we can encounter while creating those threads and while passing the arguments. Then we will see certain examples like how can we how can we convert a simple function into a periodically called function. So we'll see all these things inside this video. So without wasting much time, let us start with the code itself. So let us create a file first, say sample.cpp. Now inside sample.cpp, let us first try to create a simple thread, and we'll give a function as an argument, and we want the function to be launched inside a separate thread. So hash include iostream. Then we also have to include the thread. Let us write down a function which is, say, print hello. It's a simple function. It does not take any argument, and we are just going to say cout hello from thread, right? So with this, a function is completed. Now inside int main, I'm going to create a thread. So std thread, and then I'll give a name to my thread. Let us keep it simple, t. And inside the parenthesis, I have to pass the function which I want to call. So print hello. So only the function name will be passed. It will not be called. We are not going to call it like this. We are just going to pass the name of the function. So you can see how we can create a thread. It is using the thread class. Then we give the name, and inside the parenthesis, we have to pass the function name. After this, we also have to call the join method. So t dot join, and then a return 0. Now, what is the benefit of calling t dot join, and what happens if I won't do it? Let us try to see with the example itself. So the first thing why we call the t dot join is because it waits for thread to finish, because we have started the thread. So here you launch new thread, right? Now it may be possible that your thread has not completed the execution when you reach the return 0, or when you reach at the end of your function. So at that point, you have to call t.join. What it does is it waits for thread to complete or finish. So until the thread is finished, your return 0 will not be called. So once the thread completes its execution, then it will move on to the next statement. So why is it useful? And we'll see that with the example itself. Now let us first try to execute this piece of code. So I can say g++ samples, okay, g++ sample cpp dash o, and let us name it sample only. So it compiled successfully. If I'll execute this, you can see hello from thread is called. So this log is not getting printed from the main thread. It is rather we have just launched a new thread, and from the t thread it is getting printed cout hello from thread. Now you have called t.join. Let us comment this out and see what happens. So the point here is, when you comment this out, you will get an exception, because when it reaches the end of the function and your thread is still executing, it means in internally C++ will call terminate method on the thread, and it will abort the thread execution. So if I'll compile it now and I'll try to run this, you can see we get an error that terminate called without an active exception and abort. So this is what happens if you don't call the t.join. But is it the only way? Should we only call t.join? Or whenever we create any thread, is it necessary that we have to call t.join? No, it is not. There is one more case. Say you don't want the thread which is created right now, which is the thread T. You don't want it again to come back to your main thread. We just want that it starts its execution and it completes, and we don't want to get notified, or we don't want it to come back to the main thread again. So in that case, you can call t dot detach. So when you call t dot detach, what it does is it runs the thread independently. Now it has nothing to do with the main thread. So this is useful in some of the cases. You might come up with some scenarios where you want to use detach instead of join. So these two, either of these two has to be called. So let us again comment this out and see how we can pass arguments. So let us say my print hello function takes two arguments. It has int a and int b. And I'll also print them out. Say std cout values, and I have x, say a, and we have b. Right now, if you try to compile this right now, you will get an error because the function x is expecting two arguments right now. If you try to compile it, you will get an error. So how can we pass arguments over here? I can straight away pass 5 comma 6, which is like passing the arguments by value. So if I'll try to compile this, okay, we have commented this. We should put the comment in the beginning. Now if I'll try to compile this again, you can see it compiles successfully. And if I'll try to print this, you can see 5 and 6 value getting printed. So now these variables are passed by value. So how can we pass by reference? It may be useful in some scenarios that you might want some variables to be passed by reference. So how can we do that? So let us say you have a variable int x equals to 10 and y equals to 20. Now instead of passing the values 5 and 6, I'll pass x comma y, and it compiles successfully, and in the same way it will just print 10 and 20. What if I want to pass it by reference? So uh, if I take value a as reference, if I try to compile this right now, it will give me an error. So if you want to pass any variable by reference into a thread, after passing the reference variable inside the function, you also have to pass it over here, ref, like this. So you can use, okay, since we have not used as using namespace std, so it will be std scope resolution. So by this, by referring to this, you're passing the reference of the x into your function, and variable a will get the reference to the variable x, whereas y will be passed by value. So right now, if I'll just change my a to say 30, and then I'll try to print it after I have executed my thread. So if I'll say std cout value after thread, and I'll just print x, and y. Now if I'll try to compile this, it compiles. And if I'll try to execute this, okay, we have not given the space, but still, since we assigned a variable a as 30, so the values which are getting printed is 30 and 20. Then after the thread has completed its execution, we can see 30 and 20 are getting printed. In the same way, if I'll just say b equals to 10, but we have passed on 20 for b. If I'll try to compile this now, and if I'll try to execute this, you can see it is still 20. I can give a space in between. So let us compile this again. You can see the value of y is still 20. It has not changed to 10, even though we changed the value of b as 10 because it was passed by value. So now you know how we can pass the variables by value or by reference. Now there is one more thing where people miss is when we pass the variable by reference, then you also have to keep in mind that these variables should not go out of scope, or they should be in the memory until your thread complete its execution. Why I'm saying this is, say if I'll just create a thread over here, std thread t, and I'll say in this thread will assign this, and what I'll do is I'll keep it inside a scope. So we all know that once the variable goes out of the scope, they will get destroyed. So ideally they will not be in the memory anymore, so we cannot use them. And say I'll just put some delay over here so that we can simulate some real environment. Say this underscore thread sleep underscore for, and inside this I can pass chrono seconds and say 10 seconds I'm passing, or let us keep it 5, right? I have to include hash include ph chrono, and let us also have using namespace std also here. Now let us try to compile this right now. Okay, we got an error that x and y are not defined because x and y are now scoped. So their scope is until this block only. So let us comment this out and try to execute it again. So it compiles successfully. If we run this, now you can see it is taking slightly more time because we have given 5 seconds of delay, but it prints the values and it does not throw any exception. But you can see here that we are going to wait at this point. The thread started its execution, but in the beginning of the execution, we applied a sleep to the thread for 5 seconds. After that, we are trying to make use of A and B, and A is passed as reference. So it means I'm using the variable X even though it has moved out of this block. So because of this, it can cause some error. Right now, we are not able to see any error on our screen, but it can cause some error if you are writing this code for some production environment. So you should always keep in mind this is a kind of dangling reference, that you have passed the reference, but it does not exist when the threads are executing at that point of time. So this is in the coding practice, it is typically called the dangling references. Now, is it the only way, like creating a function and then passing it inside a thread? Is it the only way how we can deal with the execution of thread? No, it is not. We'll just comment out this block so that since it is not right. And let us create one more thread. I'll just create a thread over here. So std thread, and we'll keep a name, say lambda, t lambda. And now inside t lambda, what I'll do is I'll straight away pass a lambda function. Instead of creating a separate function and then passing it into my thread, what I can do is I can directly create an anonymous function and I can pass it over here. So say I have a lambda function and I just want to see out something. So see out, say lambda function called, right? So with this, it will start execution, and then we can say t underscore, yeah, t underscore lambda. Let us copy this right away. T underscore lambda dot join. And now if I'll try to execute, compile this, it compiles, and you can see lambda function called is getting printed. So let us also comment out this 5 second of sleep so that every time it does not get delayed. So here you can see we have directly passed the lambda function. What if I want to pass some variables? I can also pass it directly over here in the capture, and I can print the value x, and we'll also give some space over here and some space over here. Now if I try to print this, we can see value of x getting printed correctly. But this is passed by value. Again, if you want to pass it by reference, you can capture it by reference over here. So now it will capture it by reference. So for more in-depth deep dive in the lambda function, I'll be creating a separate video where we can cover what all are the ways we can capture the variables inside a lambda function. Also, how can we make use of it when we are inside a class? What all things and scenarios we have to deal with. So we'll keep a complete separate video for that. For now, this is the point that we are trying to cover. Let us also take some examples and how can we make a function periodic, like we said in the beginning. Let us take an example and try to understand the threading environment as well. So let us keep the name as test.cpp. Now inside test.cpp, we'll again write down include iostream hash include thread. So we are at the point where we just want to call a function inside a thread. Let us write down a simple code for that. So we have the print hello function, which takes int a comma int b using namespace std. And we have cout a, and we can cout b. Right. We are just trying to print the values, and we have our int main. Inside int main, I'm going to create a thread t. I'll be passing my print hello function, and I'll also pass some value, say 10 comma 20, and then I'll just call t dot join. After that, I'll call return 0. Simple. If I'll try to execute this, we have already seen that it runs successfully. Test. So we can see the values 10 and 20 getting printed. What if I want to apply some delay? Let us say I want to have a delay of 10 seconds before my print function starts its execution. One way is you can apply a delay over here. You could have also applied a delay in the main function itself, but it is recommended if you want to apply a delay before the execution of print hello, then you can apply it in the beginning of the print hello as well. Or you can have a wrapper function which can deal with this delay environment. So what I can do here is this underscore thread and then sleep for. Inside this, I have to pass seconds, chrono, seconds, and I'll just pass 5 seconds. So with this, what we can achieve here is we can apply some delay before the execution of print hello function. So if I'll try to compile this now, and if I'll try to execute this, you can see we have a 5 second of delay before it actually prints the value of the variables x and y or a and b right now. Now I want to make this function as periodic. So what can I do? So we are going to see some of the things in the future videos in this playlist, but we are going to use one of it right now at this point as well. The point here is if I want to make it a periodic function that my values of a and b should be printed continuously, let us say. So I have to keep it inside a while loop, right? So we can just comment this out over here and I can put it inside a while loop and I need something, some condition. Let us take a variable which is keep running, and until my keep running is true, you know that this cout will get called. Once the keep running will be set to false, our execution will stop. And since print hello will stop its execution, it will be completed. So then the t dot join will move on to its next statement. Now, how can we set the keep join, or where should I set the keep join? So I should set it over here, keep running. I can set it over here as false. And before this, I can again apply some delay. We can copy this out and we can apply it over here. So why I am applying this delay before setting the keep running as false? This is just a simulation that we have simulation for some task being performed. So let us say when we created the thread or when we called the thread, after that we are trying to perform some task which took 5 seconds, and then I want to stop my thread or stop executing this while loop. So I can do this way. Right now we have not created the keep running. You might be thinking that we can straight away say this. It will be a good practice, but it is not, because the normal variables, they are not thread safe. So right now, if you are trying to assign the value as false and in the at the same time we are trying to read the value, then there may be some concurrency issue that can happen. So every time you are going to run this, you will see that different count of cout will be printed on to the screen. So to keep this away from the race condition or the concurrency issue, what we use here is the atomic variable. We can also use mutex. That all these things we are going to see in the later videos. You don't have to freak out over here, but I'm just giving you a slight insight that we can use atomic variable. Atomic variables are something which are thread safe internally. So you can just write down atomic, and then we have to pass what kind of variable it has to be, since we want boolean, and then keep running, and inside the parenthesis you have to pass the initial value true. So this is thread safe. Now if you try to run this, okay, we have some error. Atomic does not name a type. Okay, so we have to include here atomic. I forgot to include the header file. Now if I try to compile this, it compiles successfully. And if I try to execute this, you can see for 5 seconds it will print on to the screen, and after that it stops its execution as it is. So this way you can have some periodic tasks being performed continuously, and after some time you can set it to false, or you can keep some conditions to stop the loop. What if I want to give some input and then I want to stop it? I can do that as well. Say instead of using some delay, what I'll do is take a string input, and inside the string input I'll say get line, and I'll pass cin and my input. Whatever input I get, I'll just check if my input equals to, let us say, stop. If I have written stop, then in that case I have to set this to false. Otherwise, keep it running. So with this condition, if I'll try to execute this now, you can see it won't wait for 5 seconds. It is continuously getting printed over to the screen. If I'll write down stop, then you have not seen me writing down stop, because like terminal, you can only see the output. But I wrote down stop and I just entered it. Since the input stream is different and output stream is different, so it will take the input. And it took the input as stop, and then it compared it with the string. Since it matches, it sets it to false, and then the loop terminates. So in this way, you can use these things to perform your operations. We have seen some of the examples. So now I think you must be familiar with the threading concepts, at least some of them. We will look on to the mutex and the thread safety in the next video. So thank you so much for watching the video, and do watch the complete video to get the complete insight of the threading in C++.